For those who did not read my message in the WhatsApp group earlier this morning, I have informed the class that today we'll be having a session conducted by your own colleagues. It's basically uh, a tutorial, I think, a tutorial, and basically how to start, how to go about in using the multi-sim software. So Shamimi uh, has already taken a class which uses the software, and she has volunteered to give us a lesson on how to start using the multi-sim software. And I thank you, Shamimi, for volunteering. So she raised up her concern about us now being in this kind of a situation whereby we are unable to have a proper face-to-face session, especially in the lab. So she feels that it's good if we have a session for everyone to learn how to use the multi-sim. Uh, so I would like to remind all the students that consider this session is a very important. Yeah, there will be no more repetition of the session, and let's take this seriously. For those who feels that they need to do any other things, kindly stop doing those things first, because through this class today, we're going to learn from the very basic, from the installation up until the initiation of at least putting up all the components inside the software and simulating it and getting some sort of an output. Okay, so I think it's good if we start our class by reciting on our own self Umul Kitab Al-Fatihah. Al-Fatihah. Amin, 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 Akbar, amin. Okay, so Shamimi, I will pass over the session to you. But the important thing that we need to learn today is basically first, we have 2 hour session today. So probably the first half of the session is focused on getting the thing installed. Probably you can start by just like a very, you say, a very casual session, just showing to all of the class how we should download and install and what are the things that we need to do to get the things running. uh, but if I'm not mistaken, this is the correct version of the software, right?
Yeah, it's a correct version. Since
Okay. So class, please do not distribute this to uh, outside of the class. This is a correct software, unfortunately. uh, yeah, sometimes we just have to make do with what we have. Okay, but have a glimpse of the software, and it seems like it's quite a useful software. So again, we're going to start with how to install the software, how to get it up and running, and maybe if we have the time, we will go through lab one, the first lab session, which was supposed to be conducted last week, but due to the restriction imposed by the administration of the university, we are unable to have it uh, in a face-to-face session. So, yeah, okay. Without further ado, I pass the session to Shamimi.
okay, so Assalamualaikum everyone. So yeah, I'm gonna share screen right now. So, so can you see my screen?
Yes.
All right, thank you. So yeah, actually the doctor already said that first I need to teach you guys how to install. I mean, is that all of you guys already installed the software or not? Because I'm kind of worried about you because yes,
Dah.
uh, everyone, semua dah ke? Dah.
Okay.
Yeah.
Okay. So can I can I conclude that all of you, 100% of you, has installed this software, because we're not going to repeat this session again, and I assume after this I'm going to give all the lab tutorials or the lab assignment, and I do not expect to get uh, uh, not to say complaints, but probably some of you will coming back to me and saying that, oh, I have not installed this and that, I need a session. So I'm going to ask each and every one of you. Aiman Iqbal, have you installed the software? Aiman?
Yes.
Okay, good. Amir Sufi,
Yes.
Amirun Fahim,
Yes.
Farah Hadani,
Dah.
okay, Fatin Adrina,
Yes, sir.
alright, Karina, Karina,
Yes, sir.
okay, good. Muhammad Anas,
Yes.
alright, Muhammad Faidi.
Yes.
Oh, there are two Muhammad Faidi here, correct? Or is it the same account being used?
I think there's a 2 5D. It's like if I'm not
Okay,
mistaken.
okay. The second Muhammad Faidi,
No, different, different.
different. Alright, one is Faidi Adlin, the other one is Faidi.
NFE.
Okay, so both Faidi, have you installed the software?
Yes.
Okay,
Yes.
good. Muhammad Haziq, yes. Alright, Muhammad Imran,
Yes.
Muhammad Izzat.
Yes, sir.
Alright, Najib, Muhammad Najib,
Yes.
Nik Akif Haziki.
Yes.
Alright, Nur Farhanis Azwar.
Yes.
Okay, Syami, of course. And then Nora Adelina,
Yes.
Tabina.
Yes.
Alright, good. Tashrin.
Yes.
Right. One Adriana.
Yes, doctor.
One Nur Adeline.
Yes, sir.
Alright, that's good. Okay. Okay, so you all have witnessed. And I'm going to conclude that all of you has installed the software. So Shamimi, we can go straight to the software and just show us how to maybe we can try the straight to lab one, right?
Yeah.
What do you guys think?
Sure.
Okay, all right, okay.
Would
I'm
agree.
going to put up the lab task in the WhatsApp group. Okay, give me a minute. Okay. Right. So I forwarded the lab task number 1. Let's do this together. Uh, let's open up the thing. Probably Shaimi, you can open up the task and show it to all of the class. And yeah, from there, and then we'll just start to plug in things into the software.
Okay. So yeah, this is the basically lab test one. Oh,
Yeah. So basically, we need to uh, put up these components inside the software, and yeah, and let's see what we can do using that software, Multisim.
Right. So yeah, first of all, you need to open the software multisim 14.2, but don't use the Ultiboard. Just use the multisim, the usual one. And if you guys can open it,
Yes.
it should be like this.
Okay.
So yeah, as you can see in here, we have the what we call it the volt, the volt which is 12, and the resistor for each of it. So for first of all, I'm going to show you how to what we call it to follow the source. So all you need to do is click on up here is a rig and kind of right the place MISC digital. Yeah, click over there. You guys already click it.
Yep.
Yep. All right. So okay. So what you're gonna do next is you're gonna first of all we're gonna put the battery. I mean the 12-volt battery. So yeah, go to the sources, and then there's go to the power sources after that. So you have all of this. You're gonna show you AC power or DC power.
Okay, okay. Let me hold that. Okay, guys, do you understand the difference between AC power and DC power?
No.
Okay, so let me okay. Be careful when you want to put in the sources. AC power is for alternating current, and DC power is for direct current. It gives different response here. So be careful. Look at the diagram properly. Is it a battery or is it a generator? Okay, so in this case it looks like a battery, so it's DC current, I mean it's DC voltage, not AC. Okay, let's put the DC power there.
So so after that you're gonna click the OK. Just put it over here. And yeah, and then close it. Yeah, I'm gonna make it bigger. So yeah, it's already prepared there. 12
Okay,
volt.
Shamimi, just in case if I were to change that 12 volt, let's put it 5 volt. Okay, how do we do that?
Just double click over here,
Mm-hmm.
and then yeah, it's already appeared here. So if you want to change it
All right.
5 volts, just delete it and then write the 5. So that's okay,
Mm-hmm.
and then it will change.
Yeah. Okay, Shami, just open up back that that double click back on the voltage.
On it or this one. Yeah.
Yeah. Okay. Okay. Okay, guys. Okay, look here. There are many options here. We can change in terms of the frequency, in terms of the phase. We can also give some sort of a tolerance. This is where, if I were to give you questions or a circuit which has these behaviors, you need to really check. Yeah. What are the type of source that I really want to look at? Okay, sometimes instead of taking just a simple DC battery, I might put there like a generator which has some sort of AC frequency, which is meaning you have to change certain frequency here and there, right? Okay, be careful. Hey guys, please appreciate this multisim because I think it looks quite easy and quite user friendly. You see, when we want to design a circuit later on, maybe you guys would go into the next subject next semester. Probably you go deeper into like VLS circuit or something like that. So this kind of software really helps. All right. Okay. Okay. Continue. Showing me.
Okay. So yeah, we already done with the power sources. So next thing is
Mm-hmm.
we're gonna do the what we call the resistor.
Mm-hmm.
So go back to the place what we call it MISC digital, and then press the basic. Click here. You guys already
Mm-hmm.
click it.
Guys.
Yes.
Yeah,
Yes.
got that. Okay, so
Uh,
in this what we call it in this experiment, we actually used the 10 ohms. So yeah, just right over here, just go over here, and then write 10. Here's a 10k ohm, something like that. Or something like 10k. That's a lot. You can go over here too if you want to make it up. Sorry. If you I mean like there's other way to make it easier. So you can double click it, click this one, and then write the value of the ohm that you want. Oh, and here.
Okay.
There you go.
Interesting that. Okay, double click it back.
Alright.
Shamimi. Okay.
There
Okay.
you go.
Just I want. Okay. Okay. Here you can see that we have several further options in terms of putting the temperature. Okay, there are temperatures. You see, sometimes when you have to simulate a circuit, electronic circuit, we have to put it into certain areas, right? When we have to design something which we have to operate or install it in a very cold temperature, uh, maybe -2 or something. You see, there are some options over here that we can change the temperature, which is, yeah, this is good. This is nice. This is nice. Take note, yeah, take note. I might do some quizzes or some kind of tuning of the circuit using all these parameters inside the software. Okay, continue.
So yeah, you already done the what we call it? Oh, sorry, the 10
Mm,
ohm.
mm.
So how is it? Okay, there's a 20 and 30. So all you need
Yep,
to do if you
yep,
just copy it and paste it here.
yep. All right.
So and yeah, there you
Mm,
go.
mm,
So just in it.
mm.
Can you guys follow this one right now?
Boleh.
Okay.
Yes, yes.
So okay. So yeah, seems like it's awkward to be have. I mean, look like this. So actually, you can rotate it over
Could
here.
you go over it one
Mm.
more time, please?
Which one? Which one?
Yeah, sure, sure.
Sure,
Go
sure.
back. Hey guys, please, let's do this like a very casual session. Kita tak ada masalah. I don't have any problem for you guys to stop Shamimi and go back wherever you want. We must make sure that everybody understand this session, because after this we're going to go fast. Okay, I'm going to go fast. I'm not going to go back into this and telling you what to do and how to put all the components. Yeah, so I'm going to just give the lab and I want to do it and give me the results. After this, I'm going to give you the lab template, how you're going to report it. And it's important that you guys not only be able to put in all the components, but also to run it, I mean to simulate it, and to be able to take out all the response in terms of the graph. What are the outputs? How does the voltage behave? Okay. So yes, please, anyone who has any questions, kindly call. I'm sorry. Kindly call. Aduh. Kindly interrupt and ask. Okay, please, Tabina. What is your question?
Just the resistor part again, please.
Oh yeah, sure. So I mean, which one? Because ini dah copy paste dah. So you mean like
Slowly, slowly. Shami, start back from where to click. How to select slowly, slowly.
okay? So yeah, go back here. If you want to click the resistor, go to back to place MIC digital. Yang warna merah.
Place MISC digital. Right,
Okay, sorry. And
right.
then go to basic,
Go to basic. Right.
and then resistor here.
Oh,
Just,
okay.
Mm,
Got it. Thanks.
just click any of it, and then yeah, that's it. And then double click and write and just write anything yang kamu nak tulis. So yeah,
mm.
basically
Got
we
it.
have 10, 20 and 30, right? So yeah,
Yes.
since I'm pretty
So,
yeah,
yeah, yeah. Okay. Good, good. Very good. Okay.
good. Just
Thank
copy.
you.
Okay. You're welcome.
Uh-huh. Okay, good.
So yeah. So oh sorry. So there you go. Since it looks like pretty messy, so yeah, you can
Yeah.
actually rotate it
Yes,
so
you
it look
can
like
rotate
this.
it. Cosmetically, it can also be changed. Okay.
So for this one, if you want to connect the what we call it the battery to the resistor, just do this. Click this
Mm-hmm.
one, and
Click what?
then
Okay. You
create
can
it
simply click the end of the node, right? Okay. All right.
and to
Very
the end.
easy. Yes.
So
Aha.
click
Very
here
nice.
and then click here. Done. We got this one. So
Okay.
yeah, for this one, I mean, actually we have done. I mean, like check voltage ada kan? Check the voltage or the
Yes, yes.
multimeter.
Yes, that's what I want to do next. Okay.
Okay, so yeah, all you have to do is go to here. There's a lot of what we call it meter generator or something, right? So go to the multimeter first. The very top one
Okay.
here.
Yeah.
This is multimeter.
Okay.
Oh yeah, I forgot. I mean, yeah. Do this first. I mean, just connect the what we call multimeter here in any way. I mean, any way you want. You can.
Okay. Can you just double click on the multimeter?
Oh yeah. Actually,
Okay. Okay. Alright. Okay. Tak apa, tak apa. Continue, continue. I'm going to say something about this. Okay, tak apa. Proceed.
okay.
Okay. So let's go back to the question. For the lab, does it? Let's open up the PowerPoint. Shamimi. Okay. Go to the next slide. What was the question? Okay, go back. Sorry. Go back to the second slide. Okay. By the end of this lab, you'll be able to verify equivalent resistance. Okay. Verify Ohm's law. Okay. How do we measure the resistance of the equivalent? I mean, how do we measure the equivalent resistance for the first circuit?
We add all the value.
Okay, you add all the value if you were to do it manually. But if we were to use this multisim to measure the equivalent resistance, how do we measure or where do we measure it? Okay, go back to the multisim. Okay, so connect back that node. Okay, right, yes. Okay, so now remember the when we had our first class, I was saying that if this is a series of resistors. These are series of resistors. Yeah, it is all connected side to side, so we can uh, simplify or we can have the equivalent resistance total by adding up all the resistance. So it should become 30 plus 20 plus 10, so it should be 60 ohm. Now that multimeter, it's called multimeter because you can measure several parameters of the electrical circuit provided you connect it correctly. Okay, so to measure the ohm, go and click the ohm button. Yes, and now take one of the end of the multimeter to the left side of R1.
Here.
Okay, and the other end go to the left side of R3. Left side. Okay, by right, if we were to simplify this R1, R2, and RT, it should be 60 ohms, right? So to verify that this is the correct, to verify that what we were saying earlier is correct. So how do we measure it now? I mean, can we, does the multimeter shows anything? Where, how do we output the resistance? I mean, how do you read the value of the resistance?
Yeah, you're gonna show it. But first, I need to. There's one thing I need to tell that you need to
Mhm.
put the ground because the I mean yeah you can show like this one, but there's an error says that yeah no grounds node was found in your circuit. So
It's
yeah,
okay. It's okay. Yeah, yeah, sure. Put it around, no problem.
just go over here because
Mm.
I mean go back to the what we call it the red one. I mean
Slowly, Shamimi. Slowly,
sorry,
slowly,
the
slowly.
place
Go to place
MIC
MIC digital
digital.
again.
Yeah.
Okay.
Okay.
Then scroll. Where do we need to scroll?
Go to the source. Just go
So
to
so ground. So grounding is grouped together with sources. It's
so
not. I don't think so.
okay. So
Oh, it's there. Okay, under DC power. Okay, all right.
yeah, this is the ground that I mentioned before. You just
Okay,
click
put
on
the ground. Mm.
just place it here. And then,
Okay.
oh, sorry. And then, yeah, you can run it.
Okay. So you click that play button to get the circuit running. All right. So how do we know it's actually running? Zero error, zero warning. Okay, now how? Okay, what's the resistance?
What's it? Yeah, you got something like a giga.
1.2 giga ohm. Wow.
But the voltage is
That's
right. But I don't know.
you see, these are the thing that we need to explore when we use softwares, right? Uh, myself, being an electrical engineer myself, we shouldn't get 1.2 giga ohms. When we get 1.2 giga ohms, it seems that there are somewhere in the circuit where it is actually not connected. I'm not sure where it is. 1.2 giga ohm meaning there's somewhere broken in the circuit.
Yeah, I think so. But I'm gonna figure it out.
Ah. Are you using the right multimeter?
Yeah, actually, yes. This is how we use the multimeter. But I mean, like,
Okay.
yeah, it's
Okay.
Um,
Can you measure it? Ay Allah,
you
banyak
can
kacau.
change the properties for the multimeter
Hmm.
because
Hmm.
if you change it to standard, you get 1.2 ohms. Like instead of the giga ohm, kilo ohm, just change everything to ohms, amps, and volts. I think it works for me.
oh yeah. Yeah. Oh no. Okay, I think I did something wrong. My bad.
It's okay. We are exploring here. We are learning. If everyone knows how to do it, then we don't need this session. Okay, can you run it again? What is the value now?
I think I did the wrong one. Oh,
Hmm.
sorry, sorry. Oh,
1.2 giga ohm. Why is it 1.2 giga ohm? Okay. Uh, uh, Shamimi, can you remove the battery and just measure from R1 to R3 without having the power source?
oh,
Hmm.
it will be mentioned that if you, I mean, like, yeah, you can actually run it, but the under will be mentioned that you have no power source to run that circuit, that circuit.
If you try doing it, what will happen? Just try removing the 12 volt and just measure.
Oh yeah, hold up. Let me show something.
Hmm.
Oh yeah, there we go. Yeah, 1.2 ohms. Yep.
1.2 ohms. That should not be it. Hmm.
I don't know.
If you remove the power source, what will happen? Just remove it. Just remove it and just measure it. Can it be done that way? Can you just measure? Is it possible? Just measure. Okay, go back and look at it. What's the ohm? What's the ohm now?
60.
You see, in real life, when you put the things incorrectly, you see, when you put the meter over there and you measure the ohms, it is not only measuring the resistance from the resistor, it is also measuring the resistance inside the voltage source.
Oh, okay,
So
okay.
now the voltage source becomes parallel with your resistors of R1, R2, and RT. Now, this is the correct measurement. This is what the equivalent circuit should be. So I think this software is very good. I like it. It's very easy. You see, This is what I mean by understanding it, how to do it in real life, and just understanding it theoretically. Okay. Remember, previously you put a voltage source over there. That voltage source itself has its own resistance inside it. Okay, it has its own resistance. So because every whatever electrical parts that you have is consisted of certain materials, right? Okay, for batteries, we have the carbon rod inside, the chemical inside it, the metal part of the body itself. All of these things has its own resistance. Okay, and if you were to change this material, it will behave differently. It might behave as a capacitor, it might also behave as an inductor, or it might behave just like a plain resistance, like what we're having now. So this is how we verify the equivalent circuit of purely resistor itself. If you were to put the voltage source, you are actually measuring not only the resistors but also the voltage source, the battery together. And by putting the meter over there, you are saying that the voltage source is connected in parallel with the resistors. That's why you get the 1.2 giga ohm. Okay?
1.2 ohm actually is there. There's no giga
1.2
ohm.
ohm.
Yeah.
Okay, alright. So, 1.2 ohm, meaning it's parallel with the resistors. So, you see, guys, you understand?
Yes, doctor.
Okay, good. Alright. So, this is basically task number one. Okay, let's look at task number two. Okay, this is interesting. Let's try this one.
All right. So there is 10, 20, 30, and 40, and
Yes,
24.
yes.
And do we need this one?
Yes, we need. This time I'm going to ask you guys to I'm going to ask you lah actually. We're
Oh,
going to measure. Remember yesterday my question was if we were to have a group of resistors connected in parallel mode, what would be the current at I4, I3, I2 and I1? Okay, let's do this. And we need the voltage source.
here, here. And
Okay, all right. So 10, 20, 30, 40.
yeah.
Okay, correct. 24 volts. Okay, now let's measure. Okay, just let's do it one step at a time. First of all, let's measure the voltage across V1, meaning we should get 24 volt across. Yeah, from that. Yeah. Hey, you guys know when no. And that is the wrong way of
Oh,
measuring
that is
voltage.
adjust for
Ah, okay. When you measure voltage, you need to measure across the source. Yes. take out that node. Now the software is confused. It thinks that you are connecting it there. If you put the same, those probes, if you put it on the same point, you're going to get 0. Okay, let's prove what I'm going to say. I just said, go back to put back the nodes together on the same line, on the same wire. Okay, now measure the voltage. It's going to be 0. Yep. You see? And you see there are two options there. You are measuring, is it AC voltage or DC voltage? The straight line tells you that you are, telling the multimeter or the software that, hey, I'm measuring DC voltage now. Just for the sake of experimenting things. Shamimi, put it into DC. Go there. Okay, what is the voltage? Okay, it is still 0 because it is sitting on the same point. But if we were to measure this on an AC circuit connected properly, the voltage is going to be different. Okay, so go back to DC. All right. So now, remember my point earlier? Any voltage, if you measure on the same point, is going to get 0. Just to give you guys a better insight of what does this means. Okay, voltage is dangerous when it has difference. When you have, for example, okay, have you seen a bird sitting or basically standing on a conductor, on a bare conductor, and yet it doesn't get electrocuted? Have you seen? Right? Okay. Do you not wonder why they did not get electrocuted? Can somebody explain to me why, when a bird is standing on a bare conductor live with voltages on it or in it, and it doesn't get electrocuted? Can somebody explain me why is the reason?
Not connect to the ground.
Their legs are on the same point.
Okay, Tabina, the legs on the same point, not connected to the ground. The answer is nearly there, but it's not the most accurate answer. Good try, by the way. Anyone else?
The distance between the legs is small.
Who said that?
Me, Tashrin.
Tashri, okay. Anybody else?
I think that.
Okay. So no more tries. It's okay. No problem. I'm going to explain it after this. Okay. Tabina was saying the voltage across those 2 points is 0 volt. Is it correct? Is that what you're saying? Tabina? Was it?
I guess, yeah.
Okay. It's actually, this is the classic example. Okay, I myself, I've worked with Tenaga Nasional Berhad for 10 years before I moved to Petronas for 2 years, and in 2015 I joined UPM. Okay, so this is basically the concept that we as professional engineers we apply this concept when we are working with high voltages. Okay, the bird sitting on the wire did not get electrocuted because the voltage across its legs are, the voltage across its legs are actually 0 volt. Why is it 0 volt? Because both legs are sitting on the same point. Okay, I think Izzat was saying that it was not grounded. It's not because it is not grounded. The circuit is grounded. The thing is, if, for example, one leg of the bird is sitting on a conductor, the other leg is actually touching the ground, then there will be a potential difference, meaning one leg is actually at the higher potential voltage, and the other one is sitting at a 0 potential voltage. Now, when there is a potential voltage difference, that is where the current starts to flow. Okay, the concept of voltage and current is that it needs to have a different in voltages. It needs to have a different potential. Like water on top of a mountain is going to flow or fall to the ground if you have certain height. If it's on the same height, it's not going to move. Just like the current. If you have 2 points with having the same potential, be it 500,000 volt, be it whatever volt it is, the current is not going to flow if you are sitting or standing on the same potential. There's no difference in potential. This is the exact classic concept or example when we as engineers working on high voltage level. It's called lifeline. It's called lifeline. We are working on it while it is actually in energized mode. You can have like 400 kV, you can have like 750,000 volts. Okay, so and the people or the person working will not get electrocuted because the whole body is having the same potential, just like what this multimeter is showing to us. Okay, now Shami, do you understand, guys?
Right. Understand. Yes, sir.
Okay, right. So good. So now let's connect one point to the other. Yeah.
Right. So point
Mm.
it back. And
Okay.
then go back. There we go.
Mm-hmm.
Yeah.
Okay. Now let's look at the voltage.
There we go. Simple.
All right. You get 24 volts because you remember. I think it was yesterday. Is it yesterday? I forgot already. Okay, the voltage across R1, R2, RT, and R4 is going to be the same. Okay, to prove that, okay, let's put the probe now between R1 to R2. Take both connection.
Zero here.
Now, just between R1 R2, put it in the middle. You can put it there also, no problem.
R1 and R2 here.
No. I mean across R1 R2. I mean across both R1 and R2. The bottom one. I mean connected to the bottom. Okay. If you guys, okay, don't change it, shall we? Just put it. It's okay. Okay, now again my question. What should be the voltage of this multimeter now?
Should be the same. I mean,
The same meaning what? The same meaning what?
24. I mean, I don't think it's gonna be the same. I mean, it's gonna be different. I mean, like yeah.
What's the voltage? Okay, guys. Anyone else wants to try? I've already give you the clue. Remember I said
0.
yes. Bagus, Adriana. It's going to be 0 because it is sitting on the same node, the same point.
Alright.
Yes. You all bila kita tukar sikit connection dah pening dah. Alamak. What with the voltage? It's sitting on the same point. It's sitting on the same potential. The multimeter is measuring the difference between 2 points. If it's sitting on the same point, you're going to get 0. So you can put the node, you can change the probe from left to right. But if you're sitting on the same node, you're going to get 0. Unless you take one of the end of the probe and put it across the voltage, then you're going to get different voltage. Now, put one of the probe to the lower part of the circuit. The lower line.
You mean this one?
Yes. Pull it down. All the way down. Yes. Okay, now, what is the voltage? Now,
24.
yeah, it should be 24. So, prove it by running the simulation. See? Okay, so I think I don't need to go through the rest until R4. It's going to be the same. It's going to be 24, 24, 24, 24 across, because that is how we measure voltage. We measure across the voltage source. Okay, now let's look at current. Okay, how do we measure current? Ah, let's try. Just put it somewhere and see what is the voltage. Okay, now we are connecting the probe uh, in a parallel mode lah. In a parallel mode. Okay, what is the current measurement now? Put back the connection, Shamimi, on the positive probe. No, don't put it there. Just put it between R1 and R2 in the middle. Just
Okay.
go straight. Yeah, there. Okay. Now, pull it down, fold it down. The negative probe. Pull it
Yeah.
all the way down.
Alright. So,
Mm-hmm.
there you go.
Okay, now let's look at the current. What is the current now? Okay, that is 2.4. Is it 2.4 amps? Okay. Now try putting the negative probe on the same line. I mean, on the same conductor. Put it back up. Okay, now what is the current now?
0.
Okay, so this is not the correct way of measuring current. I just wanted to show you that if you measure your current wrongly, you're going to get the wrong result. Okay, remember, voltage must be measured in parallel mode, in parallel connection, but current needs to be measured in series, meaning it should be connected. Okay, let's say Shamimi, you remove the connection between the top of R1 to the top of R2.
You mean the positive one?
No. Now there's a connection. There's a wire from the R1 resistor to the R2 resistor. The top connection. Remove that part. No. Remove all the connection for the meters first.
Okay.
This is the multimeter. Okay, just leave it there. Remove. Okay. Now. Yes, remove that portion. No. Yes, remove that portion. Okay. Now, connect the positive probe to the top of R1. Yes. And connect the top of, yes, to the top of R2, the negative probe, top of R2. Okay. Okay, now, let's look at the current. 2.346. Okay, 1.248. Okay. You see, when you remove that connection, then it became the value changes. Because when you want to measure current, you need to measure it in series mode. If you measure it wrongly, you're going to get the wrong current. Okay? Okay. Okay, let's see. Let's look at okay, now connect back R1 to R2, remove the connection for the meter.
Oh yeah. Hold up.
Hmm.
Let me do it.
Okay, now we're going to measure the current at R1 compared to R4. So let's measure at R1 first, but the connection cannot be that way. It should be okay. It should be, yes, it should be there, and you need to move the R1 lower so that you can put the meter next to the R1.
Hold up. I mean, like,
Tak apa, tak apa.
it need a bit longer. So yeah.
Yes, okay. It's okay. You understand. Give some space on top of the R1, I mean all the resistors as well, so that we can put the meter in series connected to the resistors. We can put many multimeters together, right, Shamimi?
Yeah. Actually, you can.
Yeah, you can put like XMM1, XMM2, XMM3. We're gonna compare the current between all the branches. Now you need to give some space on top of the R1 so that we can put the meters in series connected to the R1.
There you go. I wonder about this one. Oh yeah,
Not
doesn't.
no that okay.
There you go.
Okay, the meter should be connected in series with the resistor that we want to look at the current.
So the negative one should be where? Is it under
It
the
should be
R1?
in series, meaning it's not going to go across the resistor. It's going to be side to side with the probe, but you're going to remove the connection.
Is it here? Is it here?
No. Okay. Just put the connection of the probe beside to the positive probe. Okay. Put it there. Okay.
What's it? Oh,
No. Yeah. Okay.
it's stuck here again. Hold up.
Okay. Alright. Okay.
Oh,
Now
wow.
remove the connection between the positive probe and the negative probe at R1.
Positive part and negative part.
Okay, just highlight it. I will tell you which part to remove.
Okay.
Okay, highlight it first.
Highlight. Which one? Highlight.
Okay, between the positive and negative probe on the R1 branch, yes, remove that part.
Oh, yeah.
Delete,
Okay.
press delete. Delete
Mm,
that part. Delete that part. Can you just simply delete it? Just
but
remove it. Delete it.
I think because I run it. So yeah. Sorry. There you go. Sorry.
Okay, now this is the correct way to measure current on that branch. This is what we call as series connection. So if you were to measure the current, you need to measure it in series mode. But if you are going to measure the volt across the resistor or across a certain part of the circuit, you need to measure in parallel mode. Understand, class? Do not make this mistake. If you put it or you connect it wrongly, you're going to get the different result. Okay, now let's look at the current. What's the current?
1.2.
Okay, now do the same for R4. Put another meter. So where do we get a second meter?
Yeah, hold up. Sorry. Wrong meter.
Hmm.
There's a correct one.
Okay. Yes. Okay. Yes, remove it. Tak apa. Connect it back. Just connect the positive probe. Yes. It's the same. Yes. Okay, now run it and let's compare the current. See? It's lower.
Maybe.
Remember what I said yesterday? If your resistance is high, that branch is going to get lesser current. Okay, now let's see the current at X meter number 1. Meter number 1. Okay, it's 1.2 M DC current, yeah? It's 1.2 M DC current. Masya Allah. Okay, so it's 1.2 M DC current and it's 10 ohms. Right. So now let's go to R4.
Yep. Correct. Sorry.
Okay. Again, these things needs to be preset correctly. If you preset this wrongly, then you're going to get a different value as well. So are both meters preset? I mean, are you using the same setting for both meters?
Yes.
Okay. So now, this is you're measuring the ohm. What about we'll look at okay the current. What is the current? It's 440 amps, 480 milliamps, and the resistance is 40 ohm.
2.4 ohm. I think because of the
Okay.
DC.
Okay, yeah, because of the connection and the wires. Okay, you remember the resistance itself is 40 ohms, but the wire that you are connecting to it by right, actual in reality should have some resistance on its own. That's why you get the zero point 0.4 ohms. I mean, you get the 2.4 ohms. It's because of that wire that you're connecting to the probe.
Okay. Got it.
Okay, so now the current is 480 milliamps, and at 10 ohms the current is
At 10 ohms.
the current is 1.2 amps. Okay, so you can see now that for a branch having lower resistance, you would expect the current to be higher. Okay, at 40 amps, since the resistance is higher, you are going to expect the current to be lower. Okay, this is what I wanted to show you guys. Okay, so semua nampak? Does everybody understand my point?
Yep.
Yes.
Okay, good. All right. Okay, so let's look at slide number 3. What do you still have in the task?
Uh, yeah.
Okay. Okay, let's go to next slide. Next slide.
Or
Okay. All right, guys, go further down, further down. Okay, nothing special, nothing special.
except this one, I think is this
Yeah,
the DC?
probably because it's round in shape. Probably it's AC. Maybe I don't know. But I think at this point, most of the power source that we're going to use is DC. Maybe later on in mid semester, we're going to explore AC circuits. Okay, all right. So I think okay. Question to all. Semua faham? Everybody understand how to use this software? It's quite easy. Actually, very easy.
Understand.
Everyone?
Yes.
Yes.
Yep.
All right. Good. Okay. So I think we should stop here because I'm going to give you all the lab for lab one, task one. Complete those exercises and answer this question. What should be the equivalent resistance in resistive circuit? Remember, I've shown you if you measure with the voltage, you're not going to get the right uh, value. If you want to measure the equivalent resistance, you need to remove the power source first. Okay, but of course, you need okay. First of all, like we mentioned yesterday, series circuit needs to be add up and parallel circuits needs to be calculated using that formula 1 over RT is equivalent to 1 over R1 blah 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 blah. And then once you find the equivalent circuit, only then we can compare the calculation with the resistance measured by the meter. Okay, okay guys, understand? Terima kasih Syabimi. Very good
Okay.
presentation today. Hopefully everybody understands, and I believe everybody has declared that they have installed the software. So there should be no excuse that you are unable to do uh, the lab session. Okay, all right. So any other questions before we wrap up our class today?
Everything's fine for me. I mean, how
Yeah,
about you
okay.
guys?
Shamimi, thank you very much, Shamimi. What about the other class? I mean, the rest of the class? Anything else you want to ask, Shamimi?
No, I think this will be fine. I mean, yeah, don't forget about the template. That.
Yes, yes, sure. The template of the report, I will pass it in the WhatsApp group.
So yeah, I think everything is already clear.
Okay. So, tak ada soalan? All done? Okay. So, lab boleh buat lah? Semua boleh buat lab lah?
Boleh.
Boleh.
Boleh. Alright, very good. Okay, terima kasih banyak. I think tak ada soalan Alright, thank you very much. A round of applause to Shamimi for volunteering to conduct the tutorial session. Yay! Alright, good job. Okay, hopefully, lepas ni, after this, we can go fast with our lab so that I think it's quite easy, you know. I don't mind sharing the lab assignment to all early, awal, so that all of you can explore it. But please, I mean, jujur lah. You have to be jujur to yourself. You are learning not because simply just nak score subject tak. We are learning because we appreciate the knowledge. To tell you the truth, these are the things that when you go outside, these are the basic things that are needed. All the canggih-canggih punya teknologi usually is not going to be used pun. All the calculation yang pelik-pelik tu, all the canggih-canggih one. Normally, when something gets too complicated, people don't like it. Okay, the best solution is the simplest solution, and the basic solutions are what you've seen just now. All those parallel connection, series connection, how to measure the voltage and current, and later on, maybe we can, ask Shamimi to show us how to generate the graph, sinusoidal graph. But that one, once we come into the AC source, now we are looking at the DC source. Okay. Okay, guys. Thank you very much. Assalamualaikum. Selamat belajar.
Salam. Thank you, Doctor.
Thank you, Doktor.
Thank you, Doktor.
Terima kasih, doktor.